Hello dear students, learning chemistry is easy and fun. So let's make it learning maths is easy and fun. Why maths? Why? Because I'm going to take up a topic in mathematics today, logarithms. Why would I tamper with the topic in mathematics under chemistry? Yeah, because I need this topic for my students in order to be able to do the numericals, in order to be able to understand the derivations we have done. Just because they don't know logarithms, I don't want students to run away from numericals and to shy away from chemistry. Once you know logarithms, chemical kinetics, thermodynamics, all this becomes a cakewalk. Seriously, believe me. And honestly, when we started with logarithms in school, I couldn't understand anything at all. And I actually came home crying. And that is when my dad came to my rescue and he explained this topic so beautifully that I never had to look back. I'm very, very confident that by the end of the two videos, you too will fall in love with logarithms. So let's start with logarithms. What is logarithms? It's nothing but another way of representing numbers which have a power or indices. So let's suppose I have 2 to the power 3 is equals to 8. 2 is what you call as base. 3 is what you call as the index or the power. 8 is, we'll say, it's the value of that number or the exponential form of a number. When we write in logarithms, we say log of 8, that is the value, to the base, so this was the base, this becomes the base of my logarithm, is equals to the index or the power. So when I say log of 9 to the base 3 is equals to what? Meaning to say, to what power should I raise 3 in order to get 9? This is what is logarithms. So the two are interchangeable. You can convert logarithmic form to exponential form and exponential form to logarithmic form. So just remember 2 to the power 3 is equals to 8. That is how, if you remember this basic representation, it will be easier for you to recall and to use wherever required. So we have log of the value to the base is equals to the index or the power. If you want to solve this, 3 to the power x is equals to 3 square. Therefore, since the base is the same, x is equals to 2. Coming to the laws of indices, which we shall correlate to the laws of logarithms. Laws of indices, you know that when the base is the same and you are multiplying two numbers, a to the power x into a to the power y is equals to a to the power x plus y, right? So multiplication, when you multiply two numbers to the same base, the powers get added up. See the first rule in logarithms? Log of x into y to the base of 10. Now I'm taking to the base of 10. It can be any base. But since our knowledge in chemistry or our working in chemistry requires mostly either to the base 10 or to the base e, about which I'm not mentioning now, we'll just write it as log to the base 10. Log of x into y to the base 10. Now what did you do in exponents? You converted, you added the powers, right? So the same thing we will do over here, log of x plus log of y. So let us suppose I give you a question, log of 42 into 68. Can you write it in expanded form? Go ahead, try it. Keep a pencil and a paper handy so that you are able to get maximum benefit from this lesson. Moreover, when we are not writing the base, it automatically means to the base 10. Log of 42 into 62 to the base 10. So if I have to apply the rule of logarithm over here, this becomes log of 42 to the base 10 plus log of 62 to the base 10. Now, a very, very common mistake that many of the students do is they will not write log over here. then it becomes wrong. Why? Because in that case, you would be writing log of 42 plus 62 to the base 10. But these are now logarithmic values. So you cannot write it like this. You have to write log. You may be meaning log, but unless you write it, it is not considered as log. Coming to the second value. Second law, a to the power x upon a to the power y. So when you have two numbers to the same base, so let's suppose I have 2 to the power 3 divided by 2 to the power 1. This becomes 2 to the power 3 minus 1, that is 2 square. The same thing we apply for logarithms. So log of x upon y to the base 10 is log of x to the base 10 minus log of y to the base 10. So numerator and the denominator. The denominator becomes negative, the numerator remains positive. Try log of 42 divided by log of 62. Try this question. Try writing it in logarithmic form. Yes? Yes, very correct. You simply get it as log of 42 minus log of 62, both to the base 10. Coming to the third rule in exponents. A to the power x to the power y. What do we do in such a case? We multiply the powers. So let's suppose I have 2 to the power 3 whole thing to the power 5. 5 times 3 is 15. So 2 to the power of 15. So what do we do over here? Let's convert it into the logarithmic rule. Log of x to the power y, power upon power. So y log x. This is what our value becomes. So the power gets multiplied. Now since I have not written a base, it automatically means to the base of 10. Now let me give you a question. Paper and pen handy please, so that you can get maximum benefit from this. 5 to the power 25 to the base 10. Please convert it into simplified form. Yes, power goes out. We have 25 log of 5 to the base 10. Now, the doubt arising in your mind would be, how am I going to solve it? Don't worry. Next video, and this will also become very clear. Okay, coming to next. Now, an extension of the third law is my fifth law. See, in exponents, what do we say? Nth root of a can be written as a to the power 1 by n. So, for example, I give you, let's say, fifth root of 3. Now, under ordinary mathematical rules, you'll find it very difficult. But we will realize when we apply logarithms, this becomes very easy. So, fifth root of 3 means 3 to the power 1 by 5, right? So, the same thing we apply over here. As I said, it's just an extension of the third law. Log of a to the power 1 by n becomes 1 by n log a to the base 10. Coming to the fourth law. Don't worry, I've not forgotten it. A to the power 0 is 1. Anything to the power 0. 100 to the power 0. 1000 to the power 0. Anything raised to the power 0 is always 1. That means log of 1 to any base is always 0. Right? Any number raised to the power of 0 is 1. So simply understand, multiplication changes to plus, division changes to minus. Let us apply the rules that we have learned. I'm going to give you questions to do. Keep on writing, keep on tallying your answers with what I will do over here on the board. So let's start with the first one. log of 35 into 62 is what? Convert it into an expanded notation. First one, go ahead, keep on writing the answers. Log of 35 into 62 upon 98. Come on. Okay. First one becomes log of 35 plus log of 62. 1 out of 1 if you've got it correct. Go on. Next one. Log of, yes, the multiplications become plus log of 35 plus log of 62. How does the 98 become? Yes, it's minus log of 98. You can write it in the same line, just because I had shortage of space, that's why I wrote it in the next one. Done? Okay, if you got this correct, another 1 out of 1. Yeah, don't think that I'm trying to make it into a test. It's just to make it interesting and to give you that confidence. Third one, log of 35 into 62 upon square root of 98. So a step next. Go ahead. I'm giving you time for you to write your answer and tally it with what I'm going to write. Go ahead, yes. If you've written log 35, perfect. You've written plus log 62, perfect. Log 35 plus log 62, very correct. Minus log of root 98, correct. Can we go a step further now? 98 is, root of 98 is 98 to the power half, right? Plus log 62 minus log 98 to the power half, right? Because we're talking about square root. So this can also be written as log of 35 plus log of 62 minus half log 98. Now if you've got this one also correct, you can give yourself a nice smiley, because you've done very well till now in understanding logarithms, right? So do we go ahead and start learning how to find out the values for bigger numbers using logarithms? Okay, for that we will need the 4-figure logarithmic tables, which you will usually find it in the last part of your textbooks, or sometimes there are these logarithmic tables which are available. If you don't have, don't worry. Look out for your maths books or chemistry books or physics textbooks, any of the reference books, and get the 4-figure logarithmic tables handy. And then I shall go on to the next part explaining how to solve these, or how to use logarithms in order to do difficult calculations like log of 0.321 into 6298 divided by a root of 42.63. Wow, don't get scared. It's a cakewalk once you have those tables handy. Get those tables ready, and then we shall go on to the second video on this part. Happy studying.